Part B of Lesson 2 of Chapter 8 is on the law of cosines and some application, and we'll also talk about the area of a oblique triangle. So this example shows a vertical pole of 40 feet tall stands on a hillside that makes an angle of 17 degrees with the horizontal. Approximate the minimal length of the cable that will reach from the top of the pole to a point 72 feet downhill from the base of the pole. So you can see we've got a couple of triangles here. So we're going to use the law of cosines to find this. To start off with, since this is 17 degrees right here, then this angle right there would have to be the complement of 17 degrees. And so that would be 73 degrees. And if that's 73 degrees, that means that this angle right here would have to be its supplement. So that's going to be 107 degrees. So keeping that in mind, we now have enough information to find the minimal length of the cable that will reach from the top of the pole to a point 72 feet downhill. So we're going to use the law of cosines for this. We're going to use the 72, the 40, and the 107. So x squared would have to equal 72 squared plus 40 squared minus 2 times 72 times 40 times the cosine of 107. And so if we use our calculator on that, cosine of, what was it, 107? 107. Now we have to take this, we have to square root that. And that gives us about 92 feet approximately. So that's using the law of cosines with a side angle side case. Next example is find the distance between moving objects. It says two trucks leaving a city at the same time travel along a straight highways that differ in direction by 62 degrees. You can see the 62 degrees in the picture. If their speeds are 50 miles per hour and 40 miles per hour, respectively, approximately how long does it take for the trucks to be 100 miles apart? So, if we know that, this is 50t and this is 40t, we can use the law of cosines to find this answer. So if I use the law of cosines here, we'll have 100 squared equals 50t squared plus 40t squared minus 2 times 50t times 40t times the cosine of 62 degrees. Now if you think about this, we can do some simplification on this. We're going to have 2500t squared, 1600t squared, and we're going to have, let's see here, that's going to be 4000t squared cosine of 62 degrees. Now if you take a look on the right hand side, we've got 3 terms and they all have a t squared. So if we take that t squared out, oops, 62 degrees, taking that t squared out, now we can divide both sides to get t squared by itself. So that's what I'm going to do on my calculator now. I'm going to take that 100, square it, divide by, and then we have, let's see here, 2500 plus 1600 minus 4000 cosine of 62, I think it was, 62 degrees. and that equals t squared. So then we just square root that, and we get t to be about 2.12. And how do you think we want to label that? Hours. Does the question specify, let's see here, how long does it take for the trucks to be 100 miles apart? So I suppose it doesn't designate minutes or hours or anything, so we can just leave it in hours like that. Next we have area of an oblique triangle. Here's three formulas that you can put on your note card. If you're given angle alpha, use the top one. If you're given angle beta, use the middle one. If you're given angle gamma, use the bottom one. It's a pretty simple formula to use. Here's how it works. You can see it says approximate the area of a triangle ABC if A is 2.2, B is 1.3, and gamma is 43.2. So all that you need to find the area of an oblique triangle is you need to have two side lengths like the 2.2 and the 1.3, and you need to have the angle in between, which you can see we have 43.2. So using this formula right down here, I'll use the bottom one. We're just going to take 1/2 times A, 2.2, times B, 1.3, times the sine of that angle, 43.2 degrees. And so if you multiply 1/2 times 2.2 times 1.3 times the sine of 43.2, it should give you the area, which is right here, approximately 0.98. And we label that as square centimeters, of course, because it's an area. So here's another example. It gives us two side lengths and an angle. So again, we want to draw a triangle, even though it might not be drawn to scale. We got A, B, and C. And we've got length A is 5. Length B is 3. Alpha is 37 degrees. Okay, tricky part on this one is we can't just use the 37, the 5, and the 3, because to use the formula, you need to know two side lengths and the angle in between. So, since we don't have that, let's use the law of sines. Find the measure of angle B. And so if we take 3 times the sine of 37 divided by 5, and that equals the sine of angle B, 0.36, then we do sine inverse of that, and that gives us about 21.2. So angle B is about 21.2. And so angle C would have to equal, we'll subtract 37, we'll subtract that angle we just got there, and we get 121.8. And so, using that angle now, I can use the area formula. Area formula is 1/2 times 5 times 3 times the sine of the 121.8 degrees. Times the sine of that guy. And that gives us an area of about 6.4. And we would label that as square centimeters as well. So again, that's using the area formula. It's pretty straightforward. Just have to have two side lengths and the angle in between in order to come up with the area of an oblique triangle. Now, there's also something called Herons Formula, which if you would like to use it, you certainly can. You can add it onto your note card. I actually think it's easier to not use this formula, but you certainly can. So what this says is the area of a triangle with side lengths A, B, and C is given by this. So if you know your three side lengths, A, B, and C, and S is 1/2 the perimeter. So right here you got S represents 1/2 the perimeter. So you take the three side lengths, A, B, and C, add them up, take it times 1/2, and then you use that value in this Herons formula. What I would do if I just had 3 side lengths and I had to find the area, I would just use the law of cosines to find one of the angles, and then once I had one of those angles, then I would just use the area formula. So here is an example. It says a triangular field has side lengths of 125, 160, and 225. So let me draw a triangle, even though it might not be drawn to scale. And our side lengths are 125, 160, and 225. And so, again, here's the way I would do it, is I would find, doesn't really matter which angle, I'm going to find the measure of angle C. So 125 squared equals 160 squared minus 225 squared. Sorry, that's a plus. Minus 2 times 160 times 225 times the cosine of angle C. And so if I go to my calculator now, 125 squared minus the 160 squared, 225 squared, and then we have to divide all that by negative 2 times 160 times 225, and then we have to do cosine inverse of that, and that gives us the measure of the angle, which is 32.7. And then what I'll do is I'll use the area formula, which would be 1/2 times 225 times 160 times the sine of the 32.7. So 0.5 times 225 times the 160 times the sine of that guy should give us our area. So 9720. And I would label this as square yards. That's the way I would do it. But if you wanted to use this Herons formula, here we go. The first thing we'd have to do is find S. So to find S, we'd have to add up the 3 side lengths and take it times 1/2. So my 3 side lengths are 160, 125, and 225. $225 plus 160 plus 120. Let's see here, make sure that that's right. Oh, 125. Okay. Glad I checked. Times 0.5, and so here's your S length, 255. Then we'll use that up here on the area. We have to do the square root of 255. So square root of 255. And then as you can see, you're going to take S minus A. So 255 minus the 125. And then you're going to do S 255 minus B 160. And then you're going to do last one, S 255 minus 225. Make sure I got that right. 225. And so that should give us the same result. There you go, exact same answer that we had. I just think it's a lot easier just using the law of cosines like this. So that wraps up the law of cosines lesson. And here is your homework assignment. And that'll be due on Friday, the 3rd of April. And I want to leave you with a joke. Who cleans up the sea? You know, there's lots of garbage and trash in the sea. Who cleans it up? The answer is a mermaid. A mermaid. Good stuff.